Hello everyone, I'm Haoran from Sichuan University. My topic today is No Pie in the Sky, the digital currency fraud website detection. And first, we need to know what a digital currency fraud website is. Such websites have the following characteristics. Under the guise of blockchain or digital currency, victims are attracted to purchase a certain amount of digital currency through the statement of no investment, high return, and no risk. But the purchased digital currency is difficult to convert into cash, cause severe economic losses to the victim, as shown in the picture. They look no different from normal digital currency websites. People who lack network security knowledge are easily deceived. In recent years, digital currency fraud websites have spread worldwide, causing serious economic losses to countries and organizations. However, the current research mainly focuses on Bitcoin-related smartphone scams, phishing websites, and phishing accounts. Lack of automated tools to achieve batch detection of digital currency fraud websites. We found that the current research on digital currency fraud websites includes two categories: smartphone scams and phishing. For example, some researchers check on open-source smart contracts on the Ethereum platform, or they search on the supply-demand relationship of Bitcoin-based pawn scams, while others analyze open-source blockchain-based websites or phishing account detection system based on blockchain transactions. Therefore, in view of the above background, we put forward three questions that need to be studied. The first question is, how do we achieve the detection of digital currency fraud websites? Second, how to improve the accuracy of the detection model? And third, how to prove the effectiveness of the results? To solve these problems, in this paper, we propose a digital currency fraud website detection system, which consists of a data collection model and a data analysis model. Let's look at this figure. The workflow of the system is divided into data collection and preprocessing, website feature extraction, and construction of a digital currency fraud website detection model. The first thing we want to introduce is collection and preprocessing data. The dataset consists of normal websites and digital currency fraud websites. So, we collect websites from Alex Top 5000 websites list and Crypto Scam DB. Crypto Scam DB is an open-source dataset that stores more than 6,500 known fraud website records on many chains, such as Ethereum, Bitcoin, XRP, Nail, and so on, which can be used to track malicious URLs and associate them with their address. The collected content includes pictures, text, DOM tree, homepage screenshots, and external URL links in the secondary web pages and the home page. According to the characteristics of the dataset, we translate all other languages into English. Next, we clean the text and remove all non-ASCII characters in the data. After the data preprocessing is completed, we can extract website features. The next important step is to extract features. We divided the extract features into 4 categories: text feature, domain feature, website ranking feature, and mainstream exchange feature. As is known to all, text information is an important part of the website and is widely used to identify websites. White site is to conduct word frequency statistics on normal websites. Black site is to conduct word frequency statistics on digital currency fraud websites. Of course, the domain is also one of the important features to effectively identify a digital currency fraud website. Digital currency fraud websites have the statistic characteristics of early domain name registration, short holding time, and early expiration time. Statistics show that 93% of normal website domain names were registered earlier than 2019, while only 45% of digital currency fraud websites registered earlier than 2019. The website ranking feature is a site reflection of the popularity and the authority of the website. We can collect evolution data through the ranking and inclusion situation provided by well-known companies. The website ranking features selected in the model include AlexRank AR, Baidu Index BD, Domain Authority Value DV, and Page Authority Value PV. The most important thing is mainstream exchange feature. The characteristics of mainstream exchanges are unique to the identification of digital currency fraud website. Digital currency fraud websites use digital currency as a gimmick to lure victims. Regular digital currencies can inevitably be acquired in mainstream exchanges. So, we select the trading platform, circulation market value, circulation rate, and turnover rate, and the features. After doing the above, we can consider how to build a detection model. The detection model of digital currency fraud websites proposed in this paper is implemented based on the random forest algorithm. The random forest algorithm has the advantages of fast detection speed, high detection accuracy, good anti-noise ability, not easy to overfit, and few hyperparameters. At the same time, the random forest algorithm can get the feature importance ranking, can process discrete data, and does not need to normalize the dataset. It can be well applied to the dataset of our paper, and it can help analyze which feature has the greatest impact on the detection result. Based on the above reasons, we finally choose the random forest algorithms to apply to the digital currency fraud website's detection model. To make the detection results reach the best, we set the parameters of the random forest: N estimators, max steps, minimum sample depth, minimum sample speed, max features, and we use accuracy, precision, recall rate, F1 score to elevate the experimental results. Next, we will discuss the experimental results. The experimental results are shown in Table 1. we can intuitively see the random forest model used in our paper has the highest accuracy and the most superior performance. Its accuracy is 0.97, precision is 0.98, recall is 0.95, F1 score is 0.96, support vector machine and key nearest neighbor algorithm can also achieve relatively good classification results, but the accuracy is lower than random forest. The naive Bayes algorithms has the worst performance. Its accuracy is only 0.46, precision is 0.45, recall is 0.99, and F1 score is 0.62. To prove the superiority of our detection model, we compared it with existing methods, Tencent Security. It is a leading brand in Internet security. Its URL security center can block malicious URLs and identify phishing websites within seconds. The website type detection that can be implemented by the Website Security Center includes information fraud websites, such as fake investment and wealth management websites, and fake brokerage websites. These two types of websites are similar to the digital currency fraud websites mentioned in our paper. Therefore, we submit the blacklist and whitelist datasets used in our paper to the Tencent Security Website Testing Center and compare the detection results with our model. The detection accuracy rate is 0.55. The precision rate is 0.55. The recall rate is 0.97, and the F1 score is 0.70. So, we can get the conclusion. The random forest algorithm and extracted website features used in our paper can make the detection effect of digital currency fraud websites better. We further want to know the impact of each feature on the experimental results. Look at this figure. It shows the input feature importance score of the digital currency fraud websites detection model. But how do we accomplish this work? The idea of using the random forest for feature importance elevation is to observe the contribution of each feature on each tree in the random forest, and then take an advantage value, and finally compare these values. We use the method of elevating with the Zhiying index here. It has 4 steps. Firstly, the formula for calculating the Zhiying index is as Formula 1. Next, we get the importance of feature xj and node m. The calculation formula is as 2. Then, we get the importance of xj in the S tree. The calculation formula is as 3. Finally, normalize all the orbitant importance scores as Formula 4. So, we can get the result. As mentioned in question 3, how to improve the effectiveness of the results. So, we conducted a case study. To verify the accuracy of the identified websites, we conducted manual case analysis on 2,498 digital currency fraud websites detected by our model. by analyzing the website's text, image, domain name features, website rankings, and transaction information, we can make a relatively accurate judgment about whether the website is a digital currency fraud website. We also found some new websites as shown below. The home page of the website is showing the figure. These websites are very confusing, and they seem to be no different from normal websites, and it is difficult for people with a lack of network security knowledge to distinguish them. To draw a conclusion, in this paper, we propose a detection method for digital currency fraud websites. We extract effective features to improve the accuracy of website detection. Last but not least, compared with the test results of Tencent Website Security Center, our test results are more accurate. Thanks for your listening. That's my presentation here.